Hi again, everyone. Today we're going to talk about how to find the area of a segment. You may not be familiar with what a segment is. It is a part of a circle, so let me draw a circle here. And we're going to deal with a sector. This is what we talked about in the last video. We have the center. We have two radii coming out. And the piece that is here, the piece of pizza, the piece of cheesecake, that's the sector. Now, if we draw a line connecting the two other lines, this line here is called a chord. And what it does is it takes my sector and divides it into a triangle and kind of like the crust of the pizza, so to speak. Okay? This angle is theta. The radius is r. We are finding the area of the crust of the pizza. So the shaded blue part is the segment of the circle. Okay? So basically what we're going to do, the segment is equal to the sector minus the triangle. If you took a piece of pizza and you ate off all of the ingredient part, that would leave the crust. So this is the segment is the crust. You take the whole piece of pizza and you eat off where all the ingredients are, and you're left with the crust. Okay? There are two different formulas for this. I will give you both of them. One is in radians, one is in degrees. The one big difference about this lesson is it is very important that your calculator is on the proper setting in order to do this problem. So let's talk about the formulas for the area of a segment. So the radian formula I'm going to put over here, and the degree formula I'm going to put over here. The radian formula is area equals r squared over 2 times theta minus sine of theta. And in this case, the theta has to be in radians, and your calculator must be in radians. And I will show you on both the Desmos and our scientific calculators that we have at school how to change your calculator to radians. If you have a different calculator other than the two that I'm going to show you, send me a picture of it and I'll see if I can research how to do it, or you can actually Google it and find out how to change from degrees to radians. So the degree formula is done this way. The area equals r squared over 2 times theta pi over 180 degrees minus the sine of theta. In this case, your angle is in degrees. Your calculator is currently in degrees. So if you're going back and forth, you're going to have to check every time you do a problem to make sure that your calculator is in the correct mode. So I will do one of each and show you how this is done. We'll start with the degree mode because that's the easier one. So I'm going to actually draw a line right here, and I'm going to do the degree problem right underneath the degree formula. So I'm going to draw a circle. I'm going to draw in my radii. I'm going to say the radius is 17 centimeters, and the angle theta is 120 degrees. So our angle is 120, our radius is 17. We draw the line connecting the two. We are finding the area of this sector right here. I'm going to highlight it in yellow this time. We're finding the area of this. So now we go ahead and write our formula, and we go ahead and start plugging in the values. The area of that part will be 17 squared over 2 bracket 120 pi over 180 minus the sine of 120. I need to go back and put my degree symbols on everything to be a little more accurate there. Okay. Now we're going to go to the calculator. We're going to go to Desmos first and take a look. Now what I want you to notice right here, see what I'm circling with my little dot? That's how you change from degrees to radians. It says DEG, so it's already in degrees. So we're going to type in what was on the other page. We're going to hit the fraction bar. 17 squared. Click on the bottom for the 2. You must click the right arrow to get off the bottom. Then open your bracket. You need another fraction, 120 pi. Click the bottom, 180. Click the right arrow to get out of the fraction. Notice that the cursor moves to the right, minus the sine of 120. Now notice there's 2 gray brackets here that's telling you you need to close it twice. And my answer is 177.499. If I was going to go to 1 decimal place, that would be 177.5. So my area for that shaded part is 177.5 square centimeters. All right, that's how you do it in degrees. And you would plug it into the Casio calculators exactly the same way. Now let's talk about the radian measure. So we're going to do a slightly different problem. We're going to have a circle. We're going to have our angle. We're going to make it a little bit smaller. Let's say that our angle theta is 1.9 radians and our radius is 6 centimeters. Now, how do I know that's in radians again? If it doesn't have a degree symbol, it's in radians. I think the book is very explicit to let you know which ones are in radians. So we draw in our third line here, and we are finding the area of this crust right here, this segment. So we start out by putting everything into the formula. We get A equals 6 squared over 2, bracket, 1.9 minus the sine of 1.9. All right, that's what we're going to be typing into the calculator. Calculator is cleared and ready to go. Before we start anything, the first thing we must do is change our calculator to radians. This is a slider. So basically we're going to slide this cover over to the degree side by just kind of flicking it with your mouse or clicking on it with your mouse, and it will slide over to be radians now. Notice it says rad. So now we're ready to type it in the calculator. We put in the fraction bar, 6 squared over 2, right arrow to get out, bracket, 1.9 minus sine 1.9. Close your bracket again, and we get 17.166, which would round to be 17.2. So my area is going to be 17.2 square centimeters. All right, so now you've seen how it works when you put it in radians. Now I'm going to flip this lever and flip it to degrees. Now look how different the answer is. It's 33.6, which is a totally different answer. It thinks you want 1.9 degrees, which is a tiny, tiny angle. But if you flip it to radians, you can see that it's 17.16. So if you happen to forget until the very end and go, oh no, I forgot to put it in radians, all you have to do is flip the lever, everything's still there, and you're good to go. So now I'm going to show you a photograph of the classroom calculator. Here it is. Okay, when you do the classroom calculator, the way to change the setup, whether it's in degrees or radians, is this button right here that says setup. So you have to click the shift key and then click setup, and you're going to get a whole big menu. It says 1, 2, 3, 4, 5, 6, 7, 8. When you do that, you will see that number 3 says degrees, number 4 says radians. So I'm going to click on the 4. I'm sorry you can't see it along with me because I don't have one online, but if you go to the very top of your screen, there's some teeny tiny little letters up there. There's a little M to the left. There's a white R in a black box, and then there's the word math. The white R in the black box means you're in radians. So if you were to type that in now, you will get the same answer I did. So let's say you need to switch back to degrees. You push the shift key again, You push the setup key, and then you choose number 3 to put it back in degrees. So 3 is degrees and 4 is radians. So hopefully the problems are split up to where you do all the degree problems first and all the radian problems second, and then you don't need to really worry about it too much. That is the end of the lesson. When you go to the 2.4 page, let me remind you that the quick way to get there is by way of your tracking sheet. It's at the very top. Here is area of a segment. The book pages are linked right here, 12.06 and 12.07. Please let me know if you have any questions, and good luck with this assignment.